Hi! Today, we will learn about special parallelograms. There are three special types of parallelograms. First, we have the rectangle. A rectangle is a parallelogram with four right angles. Next, we have the rhombus. A rhombus is a parallelogram with four congruent sides. And third, we have the square. A square is a parallelogram with four congruent sides and four right angles. Let us recall the different properties of parallelograms. First, if a quadrilateral is a parallelogram, then the opposite sides are congruent. Next, if a quadrilateral is a parallelogram, then its opposite angles are congruent. Third, if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. Next, if a quadrilateral is a parallelogram, then its diagonals bisect each other. And lastly, the diagonal of a parallelogram divides the parallelogram into two congruent triangles. The Venn diagram below shows the relationship among the special parallelograms. Each shape has the properties of each group, like a square has a property of a rhombus, has a property of a rectangle, and a parallelogram. It has all the properties of those shapes. Let's have an example. Tell whether the statement is always, sometimes, or never true. First, a parallelogram is a rectangle. The statement is sometimes true. In the Venn diagram, you can see that not all parallelograms are rectangles. Next statement, a rhombus is a rectangle. Now, this statement is also sometimes true. In the Venn diagram, the rhombus and rectangle overlap. If the rhombus is a square, then it is a rectangle. Theorems on diagonals of parallelograms. Diagonals of a parallelogram may be congruent, perpendicular, or they may bisect the angles of the given parallelogram. Let's have the first theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. Say for example, we have parallelogram ABCD with diagonals AC and BD. Now, parallelogram ABCD is a rhombus if and only if AC is perpendicular to BD. Perpendicular meaning there are 90-degree angles formed at their intersection. Next theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Say for example, we have parallelogram ABCD. Parallelogram ABCD is a rhombus if and only if AC bisects angle BCD and angle BAD, and BD bisects angle ABC and angle ADC. Third theorem. A parallelogram is a rectangle if and only if its diagonals are congruent. So say for example, we have parallelogram ABCD. ABCD is a rectangle if and only if diagonal AC is congruent to diagonal BD. Fourth theorem. If a parallelogram has one right angle, then it has 4 right angles and the parallelogram is a rectangle. Say for example, we have parallelogram ABCD. Since angle A is a right angle, then it has 4 right angles. The most special parallelogram is the square, because all the properties of parallelograms and theorems on rectangles and rhombuses are true to all squares. Example number 1. In rectangle bowl, if BW is equal to 10 centimeters, then LO is equal to 10 centimeters. Because the diagonals of a rectangle are congruent. Next, if BW is equal to 4x plus 7 and LO is equal to 13 plus x, solve for x, BW, and LO. Since the diagonals of a rectangle are congruent, we can equate 4x plus 7 and 13 plus x. Combine like terms, we have 4x minus x and then 13 minus 7. 4x minus x is 3x, 13 minus 7 is 6. Divide both sides by 3, x is equal to 2. Since we already have a value for x, we can now solve for the length of BW, which is equal to 4x plus 7 by simply substituting 2 to x. So we have 4 times 2 plus 7. 4 times 2 is 8 plus 7 is equal to 15. Therefore, the length of diagonal BW is equal to 15. Since BW and LO are congruent, remember the diagonals of a rectangle are congruent. We can also say that the length of LO is also 15. Example number 2. In Rhombus Cafe, CF is perpendicular to AE, meaning at their intersection, there are 90-degree angles formed. Angle ACF is congruent to angle ECF. Angle ACF is congruent to angle ECF. So this is angle ECF. Next, angle EOF is congruent to angle AOF. Angle EOF, so this angle, is congruent to angle AOF, this one. Now, if the measure of angle ECF is 52 degrees, so this is 52, the question is, so find the measures of angle ECE, ACE, and angle ACF. ACE, so this entire angle, and then angle ACF. Since this parallelogram is a rhombus, we have learned that the diagonals bisect opposite angles. So if ECF is 52 degrees, we can also say that angle ACF is also 52 degrees. Therefore, the measure of angle ACE is equal to 52 degrees plus 52 degrees, and that is equal to 104 degrees. Let's try to answer this. Bean is a rhombus. if the measure of angle BEN is 70 degrees, what is the measure of angle AEN? So where is angle BEN? Angle BEN, here is angle BEN. The measure is 70 degrees. So the question is, what is the measure of angle AEN? Here is angle AEN. As we have learned, if this is a rhombus, the diagonals bisect the opposite angle. So if angle BEN is 70 degrees, we can also say, or we can say that the measure of angle AEN is also 70 degrees. Number 2. If the measure of angle EOB is 4x plus 10, where is angle EOB? EOB, here is angle EOB. The measure is 4x plus 10. Then what is the value of x? We have learned that the diagonals of a rhombus are perpendicular. So we can say that if the measure of angle EOB is equal to 4x plus 10, we can equate it to 90 degrees. Since the diagonals of a rhombus are perpendicular, meaning they form 90-degree angles at their intersection. So 4x plus 10 is equal to 90. We can now solve for x. We have 4x is equal to 90 minus 10. 4x is equal to 80. Divide both sides by 4. Therefore, x is equal to 20. Next, find the measure of angle EOA. The measure of angle EOA is also 90 degrees. Same with angle EOB. Same with angle BON and angle NOA. Let's have more examples. Bean is a rectangle. So look at the given figure. Letter A, BA is congruent to, we have learned that the diagonals of a rectangle are congruent. So we can say that BA is congruent to EN. Letter B, if BA is equal to 4x plus 20 and EN is equal to 2x plus 64, find x, BA, and EN. Again, we will apply our learning that the diagonals of a rectangle are congruent. So if BA is 4x plus 20, we can equate it to EN, which is 2x plus 64 in order for us to solve for x. So we have 4x minus 2x is equal to 64 minus 20. 2x is equal to 44. Divide both sides by 2. Therefore, x is equal to 22. Since we already have a value for x, we can now solve for the length of diagonal BA, which is equal to 4x plus 20. Simply substitute 22 to x. So we have 4 times 22 plus 20. 4 times 22 is 88. 88 plus 20 is equal to 108. Therefore, the length of diagonal BA is 108. Since BA and EN are congruent, we can say that EN is also equal to 108. Let's answer letter C. If BO is 5 centimeters, then En is equal to 10. So why did we say that En is equal to 10? Since the diagonals of a rectangle are congruent, or BA is congruent to En, and the diagonals of a parallelogram bisect each other, we can say that BO is congruent to OA and is also congruent to NO and is also congruent to OE. So if BO is 5, OA is also 5, NO is also 5, and OE is also 5. Therefore, the length of En is equal to 10. Let's have another example. Pork is a rhombus. Letter A, angle X is congruent to blank. We have learned that if a parallelogram is a rhombus, the diagonals bisect opposite angles. So if we have diagonal PR, it means that it bisects angle P, which means that angle X is congruent to angle Y. Letter B, angle PIK is congruent to blank. PIK, this angle. We have learned that if a parallelogram is a rhombus if and only if the diagonals are perpendicular. So if PR is perpendicular to OK, it means that at their intersection, 90-degree angles are formed. Therefore, we can say that angle PIK is congruent to angle PIO and is also congruent to angle OIR and is also congruent to angle KIR. Letter C. If the measure of angle X is 40, find the measure of angle PKO. PKO. So we are asked to find the measure of this angle. We have learned that diagonals of a rhombus bisects opposite angles. So if angle X is 40, angle Y is also 40, then angle P measures 80 degrees. We have learned that opposite angles of a parallelogram are congruent. So if angle P is 80, angle R is also 80 degrees. We have learned that consecutive angles of a parallelogram are supplementary. So if angle P is 80 degrees, it only means that angle K is 100 degrees. Same with angle O. So if angle K is 100 degrees and diagonals bisect opposite angles, then we can say that the measure of angle PKO is equal to half of 100 degrees, which is 50 degrees. Let's have another example. Clam is a square. Letter A, CA is congruent to blank. Okay, we have learned that the square is the most special parallelogram because all the properties of parallelograms and all the theorems on rectangles and rhombuses are all true to squares. So we can say that here CA is congruent to LM since the diagonals of a square are congruent. Letter B. If the measure of angle LOA is 5 x plus 30, what is the value of x? So a square, the diagonals of a square are also perpendicular. So it means that angle LOA is a 90-degree angle. So if angle LOA is 5x plus 30, we can equate it to 90 degrees. Now we can solve for x. So we have 5x is equal to 90 minus 30. 5x is equal to 60. Divide both sides by 5. Therefore, x is equal to 12. Let's try to answer this. Determine if it is a square, rhombus, or rectangle. Check the corresponding box. Number 1. All angles are right. This is true to all rectangles and squares. Number 2. Diagonals are perpendicular. So this is true to all rhombuses and square. Number 3. Diagonals bisect each other. This is true to all rectangles, rhombuses, and squares. Number 4. Opposite sides are parallel. Based on the definition of a parallelogram, it has two pairs of opposite sides that are parallel. So this is true to all. We have rectangle, rhombus, and square. Number 5, 4 sides are congruent. So this applies only to rhombus and square. Number 6, opposite sides are congruent. This is true to all of them, rectangle, rhombus, and square. 7, 2 pairs of opposite angles are congruent. This is also true to all of them, rectangle, rhombus, and square. Number 8, 4 angles are congruent. This applies to rectangle and square. Number 9, diagonals are congruent. So this is true to rectangle and square. Number 10, diagonals bisect opposite angles. So this is true with rhombus and square. Thank you very much for listening.